we are going to learn a different technique for solving a quadratic. In Chapter 9, the only way we knew how to solve a quadratic was to factor and factor the trinomial into two sets of binomials and use the zero product property. Well, we're going to see equations set up a little differently this time. The equations are going to be set up in that you'll have a squared quantity equal to something, and we're going to solve by taking the square root. Okay? So for all of these, what you're going to do is you're going to isolate the squared quantity. Okay? That's your technique. So in number 1, the only thing we need to do to isolate the squared quantity is to divide each side by 3. Then the squared quantity, which is x squared, will be all by itself. Once you've isolated the squared quantity, you take the square root of both sides. That's the inverse operation for squaring, is taking the square root. Square root, square root. And we have two possible answers for x. What are they? Patrick? Good. Plus or minus 9? I mean 3. Thank you. Because both negative 3 times negative 3 is 9 and positive 3 times positive 3 is 9. Now number 2, the squared quantities aren't together, so we need to put them together first. So I'm going to begin by subtracting 2x squared. When I do that, I get 3x squared equals 225. All right? Now I still need to isolate by dividing each side by 3. Yep, 75. Once our squared quantity is isolated, we take the square root of each side. Now we're going to, of course, simplify our rads. So what is the biggest perfect square that goes into 75? Sam? 25 times 3. So x equals plus or minus, because whenever we take the square root in the process of solving, we have to include both positive and negative answers. This would be square root 25 times 3. Take the square root of what you can, which is the 25 part. Now we get 5 rad 3 as our answer. All right, number 3, start by subtracting 15 from each side. 3x squared is equal to negative 3. We still need to isolate the squared quantity, so go ahead and divide each side by 3. Is anything squared equal to a negative? No. So there is no real answer for this one. So you're going to say that there's no real solution and just say the empty set. When you get a squared quantity already all isolated equal to a negative, we can't answer that. We're going to say there's no real solution. All right. In number 5, rather than distributing this negative 5 through, although you could do that, I'm just going to start by dividing each side by 5. Okay? Now I'd have x squared minus 20 is equal to negative 20. Add 20 to each side to isolate our squared quantity. X squared is 0. X is 0. There is no plus or minus 0. On number 6, though, I think I am going to go ahead and distribute. When I distribute, I get 25 x squared plus 25 equals 74. And you might be wondering, well, Mrs. Galvan, why did you distribute on number 6 but choose not to on number 5? Well, on number 5, I know that negative 5 goes into 100, whereas 74 isn't divisible by 25. So I figured I'd take my chances by distributing. All right, next step would be to subtract the 25. Then we get 25x squared is equal to what? 49. Still need to isolate the squared quantity, so divide each side by 25. Now, we don't need to write that as a mixed number. Leave it as is. We get x squared is 49 over 25, and I like how that works out. Because when I now go to take the square root of each side, which is always our last step, I have a perfect square of 49. I have a perfect square in 25. So the rad of each would be plus or minus, what? 7 over 5. Good, and you can leave it like that. Now, the next side, the directions are the same, okay? We're still going to isolate the squared quantity, then take the square root of both sides, simplify the radicals if needed for exact answers. We also want to practice getting approximate answers using our calculator, just because we might have some problems where our book will ask us to give answers to the nearest tenth as well. So if necessary, we might have to do step 4. So if you have your calculator with you today, go ahead and get that out. But you must show me the answers in simplified radical form, and then also rounded if it tells you to. Is that clear? Now here the squared quantity looks a little different, you guys. So don't be tempted to square this, meaning don't FOIL this out. Don't call this x squared minus 10x plus 25. Then get everything on one side and then try to factor it. Instead, notice that it's an isolated squared quantity and take the rad of each side. It doesn't matter if it's x squared or if it's something in parentheses squared, it's still a squared quantity. So rather than foiling it, getting everything on one side and trying to factor, you're going to take this method. Whenever you see an isolated squared quantity, it's easier. That gives us x minus 5 equals not just 10, but plus or minus 10. Whenever you take the square root in the process of solving, you have to consider both positive and negative answers. Now we're going to have two problems. We're going to have that x minus 5 is equal to 10, and we're going to have the x minus 5 is equal to negative 10. Remember that when we were solving quadratics via factoring, we got 2 answers most times. We're still going to get 2 answers. So add 5 over here, we get x is equal to 15. Add 5 on the other side, we get x is equal to negative 5. We obviously do not have any approximating to do here. Okay? All right, now you can't distribute this 1/2. Why can't I distribute the 1/2? Yeah, we have to follow order of operations. If we were to simplify each side and get everything on one side equal to 0, we'd have to follow order of operations. But I'm taking the approach of isolating the squared quantity. So rather than squaring and then distributing, I'm going to get rid of the fraction by multiplying each side by its reciprocal. When I multiply each side by 2, my half cancels and I'm left with x plus 9, quantity squared. 36 times 2 is 72. Now I have an isolated squared quantity. You have to, because it won't factor, you must take the rad of each side. When you do that, we get x plus 9 is equal to plus or minus, what's the perfect square that goes into 72? Biggest one?
36.
36 times 2. So we have x plus 9 is equal to plus or minus 6 rad 2. Now the way we're going to write our answer is kind of funky. You know we need to subtract 9 from each side, but this is how I want you to write it. Negative 9 plus or minus 6 rad 2. This is an exact answer. Okay? Because the square root of 2 is not a rational number, when we approximate it on our calculator, which we're going to do next, it's not going to be exact. This is your exact answer. The approximate now, use your calculator. Start by going, you have to break it up into 2 situations. You're going to go, I would maybe work backwards, take the square root of 2, enter, multiply by 6, enter, and then either add negative 9, so negative 9 plus 6 rad 2, and when you do that, you get negative 0.51 if you have it done correctly. Then, to do the next step, if you have a TI, you can do this all in one step. if you're using your parentheses right. Your next one, you can go negative 9 minus 6 multiply the second squared button, 2, enter, and you should get negative 17.49. Okay, if you're having trouble using your calculator, you can see me and I'll help you work through it. These are our approximate answers. Okay? Okay, and number 9, is the squared quantity isolated? Are you sure? Is there something being, the squared quantity, is it being multiplied by something? No, the whole thing is being squared, so the whole thing is a squared quantity. You can start by taking the rad of each side. When you square root, it cancels the squared, and you're left with x minus 3 over 2, whatever was inside, is equal to plus or minus. Let's see if we can simplify this in one step. 5 rad 2. Good. If you need to write it as 25 times 2, you can do that. Now, we need to multiply each side by 2. That will cancel these 2's. When I multiply 5 rad 2 times 2, what's getting doubled? The 5 or the rad 2, or the 2? The 5. So now we're at plus or minus 10 rad 2. And we're going to do the same thing we did before. I'm going to add 3 to each side to solve for x. But I'm going to write the 3 first, then the plus or minus, then the 10 rad 2. And those aren't like terms, so you can't do anything else. That's the exact answer. Now we are going to practice putting this into our calculator. So I think in one step, so long as you have, I think you all have the blue TIs, which are fine. 3 plus 10 multiply second square root 2, or second squared, which gives you the square root button 2. And you should get, for one answer should be 17.14. And then when you go 3 minus 10 times second square root 2, you should get negative 11.14. And notice the directions told us to round to the nearest hundredth, and that's why I'm writing the answers like that. We're just practicing writing them as approximate, just because your book might want both ways. All right, number 10, who can tell me what we need to do to isolate the squared quantity? Yes? Yes, so divide out the 9. Good. And we get x minus 7, quantity squared, equals 25 over 9. I'm not going to write that as a mixed number. Now my squared quantity is isolated. We don't need to FOIL it, to use the square binomial rule. Take the square root of each side. That will undo the squared. Square root of a squared is just what's inside. Plus or minus, what's the square root of 25? Square root of 9? 3. So now we need to add 7 to each side. So I'm going to have two answers. 7 plus 5 over 3 and 7 minus 5 over 3. 5 over 3 is not a rad, so we can actually get an exact answer just by getting our common denominator, right? So what am I going to call 7 in thirds? 21 thirds. So this is 21 thirds plus 5 thirds. So one of our answers is 26 thirds. Leave it like that. You don't need to write it as a mixed number. And so 21 thirds minus 5 thirds is going to be what? 21 minus 5? That's all right. 16 thirds. There's your two answers. You don't need to write them as mixed numbers. We don't need to approximate them on our calculator. Those are exact. You only need to approximate them when you have the rads. Is that clear? All right, two more. To isolate our squared quantity, we need to get rid of this 2 minus situation. So start by subtracting this 2 to each side. That would give us negative 24. Negative 22 minus 2 is negative 24. Equals, we can't forget about this negative sign, negative x plus 1 quantity squared. It's like there's a negative 1 there you just didn't see before. we can't distribute the negative because it wouldn't follow order of operations. Instead, we want to go with the strategy of isolating the squared quantity and dividing each side by -1. When I do that, now I have positive 24 equals x plus 1, quantity squared. The squared quantity is isolated. Take the square root of each side. The square root of anything squared is just what's inside. I'm sorry, the square root of anything squared is just what was inside, which is now plain x plus 1. We have plus or minus because we took the square root in the process of solving. Can you simplify 24, rad 24? 2 rad 6, good. Now we need to subtract 1 from each side, but I'm going to have you guys write it as -1 plus or minus 2 rad 6 equals x. Go ahead and practice approximating this on your calculator. So hit -1 plus 2 multiply second square root or second squared 6, and you should get 3.90. Then go -1 minus 2 times second square root 6, and you should get -5.90. Are you all getting that in your calculator, just doing it in one step? Good. And number 12, is the squared quantity isolated? Yes, so we can start by taking the rad of each side. So we have 4 minus x, now the squared is gone, since we square rooted it, equals to plus or minus rad 10. So you need to move the 4 over. It's positive, so subtract it over. We get negative x is equal to -4 plus or minus rad 10. Now I need to divide everything by what? -1. When I do that, it's really just going to change the sign of the 4, right? Because the positive option would become negative, but the negative option would become positive, so it's still plus or minus rad 10. There's our exact answer. Go ahead and approximate this on your calculator. Get 1 as 4 plus rad 10. You should get 7.16. And then we have 4 minus rad 10, which should be 0.84. Make sure you can get these on your calculator by yourself, because sometimes working the calculator provides us with a challenge. All right? Nice job.